We're going to look at lesson 18 here. And in lesson 18, it's just a bunch of word problems. It's going to absolutely be your favorite. I'm going to start off by reading, and I already translated on the board, but you have to learn to translate things from from English to math here. So it says the number of blues, which is B, was equals 4 less than the sum of the whites and the greens. Also, the number of greens, G, equaled the sum of the blues and the whites. And then it says, how many of each were there if there were twice as many blues as whites? Twice as many blues as whites. Now, you would think you would put 2B equals W. But if there were twice as many blues, you actually have to multiply the W by 2 to balance the equation out. If there were double as many blues as whites, then you got to double the whites to equal the blues. So you have to kind of do the opposite in this concept here. Setting it up is everything. Once you set it up, then you can solve for what's going on here. Lots of ways that you can attack this. I would probably take the B and put it in for the B here. So you end up with G equals, and B for B is 2W, so G equals 3W. And then you plug this one in for up here, so you get 2W equals -4 plus W plus G. So now we have WG, WG, and you can solve for it. We can bring the W over here so that we get 1 W, when you subtract W from both sides. Bring the G over, minus G equals -4. You could rearrange this one also to have -3W plus G equals 0. Now, I just rearranged these two equations to right here, to where you have W's and G's lined up. These actually cancel out right here. So you get -2W equals -4, divided by -2, divided by -2. The math is not difficult. It's just tracking it here. So W equals 2. So if W is 2, go up here, 2 times 3, G is 6. And if W is 2, then B is 4. Not too tough. The whole key is to set it up right. Then from there, you've already done these types. You have 3 variables, and you're solving for all 3 variables. All right, the next word problem is going to deal with money. It says the quarters, nickels, and dimes totaled 20, and their value was $1.90. How many of each kind were there if there were 4 times as many nickels as quarters? Now, whenever you're dealing with money, you're going to deal with the value of the money and then how many of each coin or dollar or whatever that you have. So you have 2 different equations here, and then this third equation they just kind of give us in the sentence. So you have 3 equations, 3 variables you can solve. A value equation means we're going to need to know the value of the money, which they said was $1.90. The inventory means how many coins are actually in your pocket. Not what is their value, but how many coins do you have. So it says the quarters, nickels, and dimes totaled 20. So that was the inventory. So quarters plus nickels plus dimes equals 20. Then it says their value was $1.90. Now, if you're going to talk about value, you've got to talk about the value of each coin. So you have 25 cents, you have 0.05 cents, and 0.10 cents. Now, what you'll end up doing on this top equation is moving the decimal point 2 on all of them, which you've done this before. As long as you're fair, move them all the same. Then it says in the third equation, how many of each kind were there if there were 4 times as many nickels as quarters? Same thing as the last equation. 4 times as many nickels as quarters. So you would think 4n equals q, but that's not true. If there's 4 times as many nickels, then you got to multiply quarters times 4 in order to balance the equation out. Now that we have this, same thing, we're going to plug the small one into both of these equations. Then really you can use system of equations on your calculator. So that's what I'll go ahead and do with this one, and I'll allow you to solve it on your own. So let's just get to system of equations, and then you can use that to solve it. So if I'm going to put n for 4q in place of n, so in place of n we're going to put 4q, so it's 4 times 5, because this ends up being 25, 5, and 10, and 190 after you move the decimal place. So 4q right here becomes 20q plus 25q is 45q plus 10d equals 190. Same thing for right here, 4q becomes 5q plus d equals 20. And you could plug this in to use system of equations. You can also multiply this times 10, so you get negative 10, so you get negative 50, negative 10, and negative 200. And that makes it really easy. When this goes out, you get negative 5q equals negative 10, q equals 2. If q is 2, n is 8. And if n and q add to 10, subtract 10, d is 10. So it's really not that tough, but you can use system of equations if you feel like that's faster. It's totally up to you guys on that. Once again, the whole key with word problems is translating them from English into math, then you just take it one step at a time there. Word problem number 2 uses the words varied directly and varied inversely. This is a chemistry type problem, something you would face in chem. And what we have here, it says reds varied directly, so R for reds, varied directly as blues squared. So blues squared. Very directly means blues goes on top. And then it says inversely as greens. Inversely means it goes on the bottom. So reds vary directly and inversely. So reds equals blues squared because it varied directly and inversely to green. So greens goes on the bottom. K is a constant, which means it stays the same no matter what the experiment or the case is. And what they're going to do is they're going to give you 2 cases of numbers. And so they said when there were 80 reds, there were 4 blues and 2 greens. Then it said how many reds were there when there were 8 blues and 10 greens. So what they did was they kind of told you how the experiment works. The reds varied directly as the blues squared and inversely as the greens. And so then they gave you the first case of 84 and 2. And then they said in the second case, if blues are 8 and greens are 10, what are the reds? Well, what you have to do is you have to first solve for the constant, which is K. You can do that because R is 80, K is unknown, B is 4, and greens are 2. Now don't forget that it's 4 squared. So you get 16 divided by 2, which is 8. So 8K equals 80. K is 10. So our constant is 10. So then we're going to plug in these numbers to find our reds, which makes it nice we're finding reds. It's already isolated. So 10 is our constant. In this case, 8 squared over 10. 8 squared is 64. So and these cancel out. And so you get R equals 64. The next word problem says this. It says the sum of the digits of a 2-digit counting number is 5. When the digits are reversed, the number is 9 greater than the original number. What was the original number? So the sum of the 2 digits, the sum of the digits of a 2-digit counting number. So we're looking at some sort of a number like 35 or 78 or 12 or whatever. It's a 2-digit number that we're looking for. And they give us some clues. They say the sum of the 2 digits is 5. So t plus u is 5. Then they say when the digits are reversed. Now, in this first one, it's just no big deal. T plus u is 5. In the second one, we're going to talk about the value of its place. Like if it was the number 37, the 3 is in the tens place, and the 7 is in the ones place. So when we talk about the numbers are reversed, so maybe it's 73, well now the ones place has a value of 10 times it, and the tens place is just 1. And then the original number, the tens place has a value of 10, and the ones place has a value of 1. It's an implied 1 in both spots here. So when the numbers are reversed, the u gets the times 10, and the tens gets the times 1. The original way it's supposed to be is the tens is times 10, and the ones is times 1. I don't know if that was very confusing. Watch that over and over until you get it. When the digits are reversed, so whenever it says when the digits are reversed, you always, every single time, write 10u plus t. Then it says the number is 9 greater than the original number. Anytime they say the original number, you always write 10t plus u. It's just something that you do. 10t plus u. When the numbers are reversed, it's 10u plus t. This is simply how you set it up. Watch these over and over in order to know how to solve for these. Once again, we're coming up with some sort of a 2-digit number. So let's go ahead and organize this. It's going to really end up the same every time. When you subtract u from both sides and you subtract 10t from both sides, you're going to end up with 9u minus 9t equals 9. Bring your t and your u down from the top and it equals 5. And I'm going to multiply these times 9. So you're going to get 4599. When you do that, the t's cancel. You get 18u equals 54. Divide by 18. Divide by 18. U equals 3. And if u is 3, plug it back in up here, then t has to be 2. But we're not just solving for t and u. They want to know what's the number. Well, the number is 23 because 2 is in the tens place. 3 is in the ones place, so the number is 23. So that actually is our answer. The next word problem is a chemical mixture problem. In fact, we're going to look at 2 chemical mixture problems. And what I drew up here were 2 buckets that you're going to pour a little bit of this mixture and a little bit of this mixture into one big bucket. And that is the chemical mixture problems type 1. It says to get 1,000 gallons of a 56% alcohol solution, it was necessary to mix a quantity of 20% alcohol and another one that is 80% alcohol. And what you're going to do is you're going to pour this one and dump this one. So we're going to use the variables P and D. And they're going to say how much do we pour of this one and how much of this one in order to get this correct mixture here. Well, in order to solve for this, you're actually going to solve for this similar to your coin problems, like your nickels and dimes quarter problems. It's a very similar way to solve for this. And so you're going to go P plus D equals 1,000. So that's going to be kind of your simple equation. The next equation is going to have it's going to be the same equation except you're going to have percentages in it. So you're going to have 0.2 P plus 0.8 D equals 0.56 times 1,000. And this is literally what you do to solve this. And you can use system of equations for this, and it makes these problems really easy. I'll show you how to do it by hand. Once again, we're going to move 2 decimal places because that was the greatest need. When you do that, you get 20P plus 80D equals 56000. And on the other side, it's P plus D equals 1,000. You can multiply everything times negative 20. And whenever you do that, this is what you end up with. And when you subtract 56,000 from 20,000, you're left with 36,000. This will cancel. You get 60D equals that. Divide by 60, divide by 60. Drop a 0, the 6 is here. So D equals 600. So D was the 80%. So 600 gallons of the 80% alcohol mixture. So if that one was 600, if it's 1,000 total, the other one is going to be 400 gallons of the 20% alcohol. And the key is you have to put the actual gallons with the percentage. So because the P and D you can switch up however you want. What has to go together are the gallons and the percentages there. That's the first type of chemical mixture problems. The next type is chemical mixture problems type 2. I actually think these are a little bit easier if you can understand how to set them up because the work is not much. You're going to need to write down this formula or put it on your formula page. And the way this formula is going to work is you have an original mixture or chemical. And you're either going to add something to it or take something away. They'll tell you in the instructions. And then you're going to get a final mixture. That's kind of like duh. You're going to start with a mixture, you're going to add or subtract something from it, and then you're going to get a different or a final mixture. I'll read it to you. It says, how many liters of a 64 glycol solution must be added? So 64, we're talking about adding in, so we get to do added, A. And I just put A because we don't know how much we're adding, but we do know it's a 64% glycol solution. How much of that must be added to a 77 liter, which is 23% glycol, to get a 42% glycol? Well, the way that I look at this is for every one of these, you're going to have a percent and then a number. A percent and a number. A percent and a number. And the way this works, they gave us this one, and then they told us that you're going to add a certain percentage. How much are you going to add? You don't know, so you just write A. To get a final percentage of 42, they told us that. And what's the final actual number going to be? Well, it'll be whatever 77 plus A is. We don't know what that is, but we can write 77 plus A because it's going to be whatever that is added together. So you can kind of see how you get these. If you struggle with these, I can go over these more in class. But that's basically how you set this up. Same thing as we've been doing. We're going to move everything 2 decimal places so that these are whole numbers. When we do that, we get 22 times 73, which I'll use my calculator. 23 times 77. That gives you 1771. So when you multiply that, 1771 plus 64A equals 42 times 77 is 3234 plus 42A. Bring the 1771 to here and the negative 42A to here. When you do that, you end up with 22A equals 3234 minus 1771. You get 1463. Divide both sides by 22. A equals 66.5. So how much glycol solution has to be added? 66.5, and this was in liters. Your answer is 66.5 liters. This is the chemical mixture problems type 2, and we have one more chemistry type problem, and that will end all the word problems. This is a ton of different concepts, so this is a video you're going to have to watch over and over again. In this third type, it is of word problems, chemical, I guess the chemical mixture type 3. This is just like a ratio box, and it says the weight of the carbon in the container of C3H7Cl, C3H7Cl was 113 grams. So you get kind of your ratio and actual. So you're setting up a ratio box here. And they said the weight of the carbon was 113 grams. And then they remind us of a little chemistry here. So this is definitely just like chemistry. Tyler will enjoy this. And they, carbon is 12, hydrogen is 1, and chlorine or chloride or whatever that is 35. But we have 3 carbons, so it's actually going to be 36. We have 7 hydrogens, so it's going to be 7. And then we have 35 of whatever this is. So it ends up being 78 is our total. And they want to know, they actually are asking for the total weight of this thing. So you do a ratio just like you normally would. 36 over 78 equals 113 over T. 36T equals 78 times 113. Divide both sides by 36. So T ends up being whatever this reduces out to. You can certainly just put it in your calculator to solve for this. 78 times 113 equals, divided by 36, equals 244.83 grams is what it was in, grams. Any of these we can look in class, but this is a video you're probably going to need to go over and over again to really understand how to do these word problems. Once again, we can look at them in class, but this is a video to definitely watch.